Greetings, ladies and gentlemen. My name is Heron Frederick Blagang, under the committee member supervision of Associate Dr. Ng Giap Weng, Professor Dr. Jason Teo, and Dr. James Mount Stevens.
What is emotion classification? Emotion affects humans both physiologically and psychologically. There are two sets of emotion, positive and negative. Positive emotions are more associated with improving the human health and work efficiency, while negative emotion could cause health problems. The example of positive emotion can be categorized as happy or surprise, while negative emotions are associated with sad, anger, fear, and disgust. Emotion classification is divided into two classes: primary emotion such as joy, sadness, anger, while secondary emotion which evokes mental images that correlates memory or primary emotions. Two-dimensional model based on valence and arousal. Multi-dimensional space model aims to specify emotion at a deeper level. For example, happy can be described as a little bit happy or happy. The figure shown is Russell's valence arousal scale, which shows 4 quadrants: high arousal positive valence, high arousal negative valence, low arousal negative valence, and low arousal positive valence. Importance of emotion classification. The importance of emotion classification is the application which it can be contributed to health rehabilitation, game development, and entertainment production. For demography and hardware, we have collected 30 subjects which consist of male and female subjects with the age ranging from 20 to 28 years old. The hardware that we use is a wearable from Empatica Evo, which collects ECG and EDG signal. Then we use a HTC Vive VR for the subject to view the video in 360 degrees. For machine learning, the programming language used is Python with 3 different classifiers: SVM, KNN, and random forest. The classification is done with intra-subject, which is individual, and inter-subject, which is overall. Next is the methodology. After the subject wears the wearable and VR headset, they will be presented with 360 videos of calm, angry, sad, and happy for 80 seconds per emotion, with 10 seconds of rest in between. Then the Excel file .csv data was downloaded for pre-processing. In pre-processing, the data is synchronized with the video timing before the classification is started. In the classification phase, RStudio is used with SVM as the classifier for the result. Experimental setup. The picture A shows the Empatica Evo wearable, while the B picture shows the Evo real-time app for live monitoring, and C shows the HTC Vive VR headset on the subject. This is the classification result for ECG data using SVM with parameter tuning. RBF1 performed the best when compared to RBF2 and RBF3. The highest accuracy is from subject 17 with 95.3% for RBF1. Overall, RBF1 performed the best for ECG data, with one subject getting above 90% accuracy and 8 subjects with above 80% accuracy. For inter-subject classification, RBF1 performed the best with 42.1%. Next is a comparison for ECG data for SVM, KNN, and random forest classifier. Each of the classifier has 100% accuracy for intra-subject classification. Subject 17 yielded the highest accuracy for all 3 classifiers with 100%. SVM has 2 subjects with above 90% and 7 subjects with above 80% accuracy, while KNN has the highest number of subjects achieving above 90% with 3 subjects. SVM is the best performing classifier for inter-subject classification with 41.4%. Next is the result for EDG data using SVM with parameter tuning. The graph shows that the 3 classifiers perform slightly similar. However, RBF1 has 1 subject with the lowest accuracy. Both RBF2 and RBF3 has the highest accuracy for intra-subject classification with 99.6% from subject 5. While RBF1 accuracy yielded 98% from subject 5, both RBF2 and RBF3 has 7 subjects getting above 90% accuracy. The best performing classifier for inter-subject classification is RBF2 with 44.1%. Next is a comparison for EDG data for SVM, KNN, and random forest classifier. All classifiers perform similarly except SVM has 1 subject with the lowest accuracy. The highest performing classifier for intra-subject classification is random forest with 98.4% from subject 4, while both SVM and KNN yielded 96.9%. With random forest, 4 subjects yielded above 90%, while none subject yielded above 80%. The best performing classifier for inter-subject classification is random forest with 51.2%. Next is discussion. The highest intra-subject classification accuracy is 100% using ECG data with SVM and KNN and random forest classifier, while the highest inter-subject classification accuracy is 51.2% using EDG data with random forest classifier. Overall, RBF2 and RBF3 performed the best with 7 subjects yielding above 90% accuracy with EDG data.
In conclusion, 2 papers were sent for conference at ICON-GETTEC and ICEA. ECG combined with EDG data classification were performed with SVM and KNN classifier.
For future work, the focus will be on comparing ECG and EDG data, then ECG combined with EDG data using Python and RStudio. Next is classification using feature extraction, Fourier transform method, and using augmented reality as the stimuli. Then focus on writing thesis and further or add-on experiment. This is the Gantt chart. Currently the focus is on analysis and writing thesis and paper. This is the Gantt chart. Currently the focus is on analysis and writing thesis and paper. This is the reference.